while it is ready to use. All right, I was discussing about the measurement model, and I have told you that in case of measurement model, you need to see that how your indicators or your observed variables are basically measuring your constructs. So in this case, it is shown that the factor loading value is greater than 0.70. So it means that they are accurately measuring your constructs. So you need to see that these are the indicators that can accurately measure the constructs. If some indicators are showing a value less than, for example, 0.60, you can simply delete that indicator, and you can simply rerun the procedure again. So in this case, if you can see the employment engagement, it is showing that some of the indicators are missing over here, like ENG1 is here but ENG2 is not here. In the same way, ENG4 and ENG5 are not here. ENG7 and ENG8 are not here. So the researcher may have deleted those indicators in order to correctly measure the employee engagement. So this model is considered as a measurement model because it shows how your constructs has been measured. The second thing is the factor loading or outer loading. This table is automatically generated when you estimate your measurement model. I need to see whether the program is ready. Yes, it is ready. So let's start from here. You need to provide a new workspace for your work to do at Smart PLS. You need to click here. You need to select the location where you want to show your work done. Like for example, I want to show my PLSM training. For example, this is the name of my workspace that I need to provide here, but I need to select a folder. The folder name is my PLS training. Basically, you need a blank folder here in order to select as a workspace. So I have selected a workspace with the name of my PLS training. So this is my workspace. Now what you need to do, you need to select a new project, and you can name it, for example, my PLS model. You can create it. And now the four options are open over here, but what you need to do is you need to import your data. You can import the SPSS data. You can also import the you can say CSV files. As I have loaded here a CSV file of one of my article that is under publication stage. So I can use it to demonstrate how I have analyzed that data. So it is importing the data. That is a CSV file. So you need to click on import button, and it is showing that there are 47 indicators, and sample is 432 and missing value is 0. You can also see the raw data. If you click this button, you can see the raw data. Here you can see how the indicators are basically numbered, how they are placed basically. So you can see the values over here. So you need to go to the back, and you need to create a model. So when you click create model, they will ask you what type of model you need to use. So simply select PLSM, because today we are discussing the PLSM and tomorrow we will discuss the PLS CBSM. So you need to click on PLSM, and you need to write here measurement model, because first thing that we need to create here is the measurement model. Just click on the save button, and you will be directed towards a screen like this. You will see PLSM measurement model blank area. You can see the variable section of your data. You have a ribbon bar that provides a number of options for you. So I will show you. There is a service convenience, there is a perceived ease of use. So service convenience, that is basically SE1, SE2, and SE3. So I can select these three variables, these three indicators, that is service convenience. Just click enter and it will generate like this service convenience. So I can change the direction of my indicators, and it is showing like we have um, a reflective constructs. So next thing is perceived ease of use, PEU, that is this variable. I need to select all the indicators. I need to drag them. I need to press enter. It will shown like this. I need to adjust them or align them on the left side. I need to realign them. Then what is the next thing? The next thing is perceived risk, PR. I need to see here, there is a PR1, PR2, PR3, PR4. You need to drag them. You need to click enter, and you can also adjust them on the left side. And the fourth one is privacy and security, PNS. PNS, privacy and security, that is PS. So there are four indicators. You need to drag them, you need to click enter, and you will adjust like this. So how can we form a model like this? So we need to have some adjustment, like for example, how can I adjust that it will look attractive? You can adjust some of the variable to that side which is more convenient to specify them, like I can change the direction of it, like in the top side. I can change the direction of this in the bottom side. I can place it like this. And what we need to do, we need to do, yes, this is also with four variables. I need to place it here, uh, left side, yes. And then I need to place in the upside to make it more adjusted model. So it will look like this. Yes. Now, what next thing I need to have? I need to have financial well-being constructs. So I need to find it from here, like FW1 to FW6, that is financial well-being variable. So this is how I have created it. Now, if I am going to analyze the impact of these exogenous variable on financial well-being, how can I analyze this? First thing that you need to do is just select all of them and change their color, because in the smart PLS, the more attractive color is black and white. So you need to click on it. Then you need to connect all these constructs as a exogenous variable with your endogenous variable. So there is a button here with the word connect. You simply need to drag your arrows from your constructs like this, like this. If you need to adjust the name of a variable, like you cannot clearly see the name of this variable, you can change it. You need to go to the select button, and you need to put it from here. If it is not being selected, let's suppose we are readjusted, yes. Now you need to single click it. You need to place its name. It was they have provided this facility in PLS4. It was not available in PLS3. So you can place the name of the variable everywhere, anywhere that you want, that you find convenient for you. So for example, I place it like here. So it is basically become the research model. because there is no value of any factor loading here. You can take you can export this image to your document if you want. You can right click over here, you can click on export image. uh, you can uncheck hide comments. It will provide svg or png file. I will normally recommend you need to have png file. So just go to your required location and you need to put this, for example, a folder, data analysis for my training. You just need to write the name it as a research model and you need to save it. You can check it whether it was created or not. It will show you directly in this form, but you need to go to your location, like data analysis for my training, and yes, it is here. You can create a word file for your data analysis, like for example this data analysis. You can open this file and you can put this image into that file as a with the name of research model. You can go to the insert button, you can go to the picture, and you can go to the this device. You can click here and you can find this picture like this. So you can create it and you can name it as a research model, as a figure one research model. All right. Next thing you need to do is you need to create a measurement model. How can you create the measurement model? Just go to your screen and you have here a button named calculate. You just need to click it. You need to run PLSM algorithm. Just click it and you need to click on factor. You may use the path instead, you may use the factor, both are giving the same values. So preferably you should need to select the factors, and it should be standardized factors. And you don't need to change the initial weight, you just need to click on the start calculation and it will calculate the factor loading value for your model. So you can see here the factor loading value in this model, just like I have previously explained in a research paper, that these values should be greater than 0.70. If a factor is showing the value, the factor loading value greater than 0.70, it means your indicators are measuring your constructs significantly. And these are the indicators that need to be included in this study. So in this case, I have three indicators and these are also showing a value greater than 0.70. Here you can see there are four values showing the value greater than 0.70. These are the indicators which are showing the value greater than 0.70. So all of my indicators are showing a value greater than 70. Here you can see some values. These are the path coefficient. This is showing the negative path coefficient. These are showing the positive path coefficient. It means if we conclude here, the PS, the SC, and the PEU is basically positively influencing the financial well-being, while the perceived risk, which is PR, is negatively influencing the financial well-being. So what we need to do, we need to simply adjust this model and right click and export image. And you need to export image and you name this model as a measurement model, because previous one was without any value. So you need to save it as a measurement model, and it will show you the output file like this, but you need to open it in your Word file. Go to your Word file, go to insert and picture this device. You need to go to the measurement model and you can open it like this. So this is basically figure 2, which is measurement model. Figure 2 measurement model. So what we have done till this level, we have basically completed our first part of the steps of the required number of steps that I have mentioned over here. In this slide, demographic summary, you may compute from SPSS. I have computed the measurement model. Now I need to calculate the factor loading, but it is already calculated here. So how can I find out my factor loading? You just need to go to the left side of this box and you can see here the path coefficient. You can see here the outer loading. So you simply need to click on outer loading table and you need to copy to the Excel. You need to go here and you can put here Control V and you can place your factor loading value here. You can convert it into tabular form, just select them, just go to the tables, all borders, but it is not appropriately uh, considering it. So how can we make it appropriate? There is a simple way because it has copied your file into Excel. So we need to open Excel sheet. So let's suppose I have an Excel sheet over here. You can open it and you can place your copied table in your Excel sheet. So it will accurately format your factor loading values here. You just need to click Control V and it will place like this. So you have your factor loading value. These are the value you have seen in your measurement model also. So you just need to select them. You need to click the center adjustment like this. You need to select you can place them in a single column. You might have an option here where you can form them like list, but this is not appropriate. I would suggest that you can manually set them like you need to cut them from here, you need to paste them here, again you need to cut from here and you need to paste it here. Similarly, the other values also, you need to cut from here and you need to paste it here, and then you need to cut from here and you need to paste it. What next thing you need to do? Basically, these are the factor loading of financial well-being. So you can have a row and you can put a name, financial well-being. You can adjust the length of your row. In the same way, you can place another row here. You can put the name like what was the name of PEU? PEU was perceived ease of use. So place the name over here, perceived ease of use. Yes, this one. You can again adjust your rows. Then you can insert another row from here. PR was basically the perceived risk. Perceived risk. All right. Then next is you have PS. What was basically the PS? PS was privacy and security. So privacy and security was the constructs, and these are the factors. And then there is a last construct name as SC. So you need to see what was the name of your variable SC. SC, that is service convenience. So you need to put its name here. That is service convenience. So you need to remove these from upward because you have created a table of factor loading. So you need to please place here the name factor loading. These are basically the standardized factor loading of your constructs. So what are the guidelines regarding these factor loading? I have provided some guidelines here like this. You need to understand it, especially those who are new. So you have calculated factor loading like this. So what are the guidelines? Generally factor loading above 0.7 are considered strong. So if you have a factor loading, it means these value should be greater than 0.70. They are considered strong. But if you have a factor loading between 0.4 to 0.7, they are moderate. They may still be accepted if decreasing those factors can cause the elimination of your constructs. You can consider the value between 0.4 to 0.7. But if you have the factor loading less than 0.4, you may consider the construct is very weak. So you need to exclude that factor. But always remember, if you have a lot of factors that are measuring your constructs, you may need to consider 0.7 as a cutoff criteria, and you may need to remove those factors who have less than this value. So this is the basic criteria of factor loading. If we can see here, in case of our this table, you can see that each value is greater than 0.70. You can see here. So our criteria is met, and we can conclude here that these factors are accurately and significantly measuring their constructs. So these three factors are accurately measuring service convenience. These four factors are accurately and significantly measure privacy security. These four factors are considering accurately and significantly measure perceived risks and so on. So what is the next thing that we need to do? According to the step-by-step procedure, we need to consider next thing is conversion validity. So there are a lot of things in conversion validity. We are going towards the factor validity and reliability. So in conversion validity, we need to highlight the Cronbach alpha, the composite reliability, and average variance extracted. So how can we find these values, the three values for finding out conversion validity? We need to go to the PLS screen, and here you can find constructs reliability and validity. That is the thing that we needed at this level. You just need to click here, and you will find here the Cronbach alpha, the composite reliability row C, and average variance extracted. So what you need to do, you just need to copy them to the Excel. You need to put in another sheet like this. You have two composite reliabilities. I would prefer that you need to consider the first one, and you need to click the second, or you need to delete the second composite reliability. You need to have these three values. So just adjust them like this. Now, how you can put this? Always remember, these values are calculated for the constructs, not for the indicators. So I need to put these values in front of the constructs, not in front of the indicators. So how can I do this? I need to copy their header first, and I need to put here their headers like this. Yes. It is better that you need to have them in the first row. All right. You can have short word. You need to use the short word for indicating them. Like factor loading can be indicated by FL. Cronbach alpha can be indicated by CA. Composite reliability CR, and average variance as it is also indicating by AVE. So it is a better way to indicate them, because when I create a publishable document, I need to provide a table which usually fit on our on the size of the page. So I need to put composite Cronbach alpha, composite reliability, and AVE in front of financial being for FW. So you need to go here, you need to select financial well-being, and you need to copy these values from here, and you need to put these values here. So it should be indicated in front of your constructs, not in front of your indicators, because these values are computed for the whole constructs, not for the individual values. Next, you need to see perceived ease of use. Here, this is perceived ease of use. You need to copy the relevant row, and you need to put these values here like this. Then you need to put perceived risk value from here. Perceived risk is here. You can copy these values from here, and you need to put these values from here like this. You can adjust the columns. Then you need to put the value of privacy and security, that is PS, like this, and you can place here like this. All right. Then you need to provide the service convenience values from here, and you may place like this. Now, we have done the convergent validity part. These are basically the three things that we needed as a convergent validity: Cronbach alpha, composite reliability, and AVE. Now, what is the decision criteria? We have considered our decision criteria for FL only. We have considered that a value of factor loading should be greater than 0.70. In the same way, the same is the criteria for Cronbach alpha. The same is the criteria for composite reliability, that the value should be greater than 0.70. But for AVE, the criteria is the value is should be greater than 0.50. Here are the guidelines that you need to see here for your convenience. Yes, this one. If you can see, I want to show you. In case of Cronbach alpha, you need to have a value of 0.70 or higher. In case of composite reliability CR, you need to have a value of 0.70 or higher. In case of average variance extracted, you need to have a value of greater than 0.50. So we can analyze these values whether we have met the criteria or not. So we can see, we can start from composite Cronbach alpha and composite reliability. They both have the value greater than 0.70 for this, same for the this, and this value is very high for composite reliability. You can see here the values are greater than 0.70. Next, you can see whether AVE is greater than 0.50. Yes, this is greater than 0.50. Yes. So we have concluded here that our convergent validity and reliability is met. We can say here, we can conclude here that according to convergent reliability, our constructs are reliable. They are valid and reliable according to convergent reliability. So we need to copy this table from here, and we can copy from here, and we need to put here as a table 2, because table 1 is basically the demographic summary in a sequence. If we see, the first table should be demographic summary. So the convergent validity and factor loading should be considered as a table 2, factor loading and convergent validity. You can place here the table, and now you can select the whole table like this. You can go to the table option here. You can put all borders and you can adjust this table. I want to show you the whole picture of the table. Just like this, you can adjust it and it will look like a publication document like this. And you can write here the constructs and indicators, because this is constructs and this is indicators. So here the constructs and indicators are involved. So you can also align them on the left side because they are title of your constructs. You can align them like this. You can select the whole of your table again, no border. Then you select the first row, go to the table, select bottom border, and then select the top border. And then you can go to the bottom of your table, select the last row, and then go to the table and select the bottom border. Now it will looks like APA style of table. It is basically, it has become the APA style table, which is which you can include as a publication document of your article. It will include the factor loading. It may include the composite, the Cronbach alpha, the composite reliability, and the AVE. So we have completed the second step of our smart PLS process. Now we can go towards the next step. So what is the next step? If we see here, next step is discriminant validity. How can we find it? Just go to the PLSM, and in PLSM, after the constructs reliability and validity, you can find the discriminant validity here. You need to select here, click here, and you can find the HTMT matrix. You can find the Fornal-Larker, and you can find the cross-loading. These are the three things that you need to report. Some of the researcher report only HTMT ratio, some of the researcher report HTMT and Fornal-Larker criteria, and some of the researcher report HTMT, Fornal-Larker, and cross-loading. So these are the three criteria of discriminant validity. So here you can see in this bar, you can see in this slide, in case of discriminant validity and reliability, you need to have HTMT ratio, Fornal-Larker criteria, and cross-loadings. So what is the difference between convergent validity and reliability and discriminant validity and reliability? There is a slightest difference. When you want to analyze the construct's reliability and validity internally, it means you are comparing a constructs by itself. You are basically referring to convergent validity and reliability. When you are comparing the constructs by itself, it means if I am comparing my present performance with my past performance, it means that I am comparing myself with my present performance and my past performance. So it is the case of convergent validity. So whenever you are comparing a constructs internally with its own values, you are dealing with the convergent validity. But whenever you are comparing a constructs with other constructs, so in our study, there are a lot of constructs here, like perceived ease of use, like perceived risk, like financial well-being, and so on. We have other constructs too. So when we are comparing a constructs with other constructs, we need to compare their factors in some cross listing order. Then there is a discriminant validity. It means if I am comparing myself with some other guy or with some other researcher, I am basically discussing the discriminant validity, because I have my own feature and that person may maybe have his own feature. Every person is unique. Discriminant validity assumes that every construct is unique and its indicators are unique. So in case of discriminant validity, you need to consider the external validity of the constructs. So these are the three criteria. So what things we need to notice in case of uh, convergent validity? How can we consider whether the value is good or bad, or how can we assess these values? I have discussed yesterday that there are some criterias, but I need to put the table first. First, you need to select the htmt table, like this. This is htmt table. You need to copy this table and you need to put this table in like sheet 3. You cannot merge these tables, so you need to put this table here first, and we need to analyze this table first. So how can you analyze the htmt table? I can write here the name, htmt ratio. The next thing that I should copy from here is Fornell-Larker. I will let you know how can we decide whether the external validity is there or not. You can place in another sheet your Fornell-Larker table, like this, and you rename here the Fornell-Larker criterion. This is another criteria for discriminant validity. And the third one is cross-loading, that you need to copy from here. You can copy the table, copy to the Excel. You need to place here, you need to adjust it, and I will let you know how to interpret these values. I will write here the name, cross loadings. So the time is going to end for another meeting. Please join again from the same link, so that I will start from interpreting the discriminant validity. And let me conclude everything in the next session, because discriminant validity is very important in considering the smart PLS. So please join again, because I need to conclude the session by interpreting these values. So join using the same link, and you can ask any question in the next session if you have any. So please join.